Cool. Well, thank you for coming to the July Brighton Kotlin. It's pretty cool to see so many new faces tonight. So thank you for those who played a part in getting everybody here. So tonight we've got a couple of things. We've got an intro to Brighton Kotlin and Silicon Brighton, and then we've got a talk on Apache Pulsar with Kotlin coroutine and flows. So for those who haven't been here before, Brighton Kotlin's been around since about 2019, and more recently we've been lucky enough to have the support of Silicon Brighton, who help support with promotion and support with all the audio and visual stuff. And I kind of say this every time, but the meetups locally probably wouldn't exist without Silicon Brighton's help. They support an absolute ton of local meetups, so their support is always very welcome. We've got Grace here, who is from Silicon Brighton. Do you want to do a bit of an intro?
Thanks, Lee, and hello to everyone, and thank you for coming. Yeah, second what Lee said, it's great to see new faces here as well as familiar people. So yeah, hope to see you at some future events as well. So I'm Grace and I run Silicon Brighton. Basically, we're a community initiative and our whole mission is around supporting digital growth in the Southeast. So basically, we put on lots of different tech meetups across the city, like this one, but across front and back end, web development, coding, programming, UX, project management, lots and lots of different sort of stuff and skill sets and themes, providing some similar sort of support, basically just to kind of keep the tech industry thriving. And it is really a sort of thriving industry where yeah, everyone's really keen to kind of get out and about and network and meet new people and share new ideas. So we just kind of want to keep that happening, really. So please do check out the other meetups that we support. Have a look on siliconbrighton.com or connect with me. I'm Grace Pryor with an I, and I can tell you all about all the other stuff going on. And please do come to some other bits and pieces. These are all our members. So basically, businesses pay a nominal amount every month to become a member, and that basically funds what we do. So these are all the fab businesses that kind of exist locally, although some of them are global and international, and that keeps these meetups free. So thank you to all the people on the slide here for the beer, the pizza, Charlie, the space, all of that kind of stuff. That's that. Next slide, please, Maestro. Back one, thank you. Yeah, so in terms of upcoming events, there's loads of stuff happening this week and the rest of the month. But this is a really exciting one because it's the first time we've actually marched with Pride. So that's Saturday, the 5th of August. We've booked a walking group for 50 people. And basically it's for our meetup community to come and get involved. So yeah, check us out. It's on Eventbrite. Space is limited, but please feel free to get involved and march with us, or tell someone else if there's anyone in your community who might want to. Next and final slide, thank you. And yeah, this is hopefully just an idea of kind of the breadth and quantity of events that we put on week. We've got Brighton Cloud tomorrow. That's at a local company called Motorway. JavaScript Brighton is happening on Thursday. That's at the Walrus. Very much just a social, kind of grab a pint and have a chat to some JavaScript people. Brighton Data Forum is happening next Wednesday at Barclays Eagle Lab. And then we've got a social for People and Culture Club, so very much focused around people, HR, diversity. I know there's a few recruiters in the room, so sort of talent acquisition, retention, that sort of stuff. And that's happening at Shelter Hall on the 2nd of August. And that's it from me.
Cool, thank you. So I won't keep you any further. The talk tonight by Michele is on Apache Pulsar and coroutines. He was hoping to be here tonight in person, which would have been great, but unfortunately that wasn't to be, so he very kindly offered to present online. So I'll hand it over to Michele. All right.
Hello, can you guys hear me? Hey Lee, can you hear me?
Hi, could you say hi?
Hello.
There we go. Perfect.
Hey, how you doing? Nice to be here.
Okay,
Hello,
perfect.
can you hear me? Hi, everybody. Hey, I'm Michele. Glad to be here. I mean, as Lee was saying, I'm sorry I couldn't be there. But yeah, here I am. So I'm really glad, to get the chance to interact with the community and basically today present like Apache Pulsar and what you can do with Kotlin in terms of like producing and consuming messages, right? So in general, I would prepare slides for such a presentation, but then again, I don't want it to be boring. So instead, what I'm going to do is I'm going to give you a very brief introduction about Apache Pulsar, what it is, what it could be useful to you for, and also like I'm going to jump into live coding and share some code that I prepare in terms of tests, right? So first of all, what is Apache Pulsar? Well, Apache Pulsar is essentially like a next-gen messaging solution that was built for cloud-native environments, right? It is, to an extent, very similar to Apache Kafka, which is very popular these days. I'm sure you guys heard about it, and if not, I mean, go ahead and check it out. But essentially, the way it works in a way similar to Kafka, or the main basic idea is that you produce messages and then you can have consumers which process these messages, right? And this can lend itself to like many use cases, including event-driven applications. Now, why am I talking about Pulsar in particular as opposed to Apache Kafka? Well, first of all, because it's a little bit newer, so you folks probably didn't hear too many things about it. It wouldn't be as interesting as if I was talking about something, intimately. And on the other hand, the reason why I'm talking about Pulsar is because I had the chance of using it recently for a use case where Kafka really didn't, I don't know, deliver for me, and I wanted to explain the reasons why I liked it more, right? So long story short, Apache Pulsar does a couple of things better, and I'm gonna show it in the code in a minute. And in particular, it has a more flexible broker approach, and this allows you to basically like handle partitions in an easier way as opposed to Apache Kafka. So let's dig into it. I'm gonna show some code. So here is a very boilerplate kind of like Gradle project. I mean, I'm basically like later on you can find the URL for the GitHub repository with all the code there. So I'm not gonna go too much into it. But for people to understand it, basically I'm using Gradle as a package manager. And I'm using JUnit essentially for testing, right? So I'm gonna try to work line by line and then run some tests. So first of all, I'm instructing JUnit not to create a new instance of this class for each test function, which seems to be the behavior in general. And this is quite inconvenient because when you use test containers like I'm doing here, line 33, this would basically create new containers for each function, which take forever. And as I was saying, like I use test containers to spin up Pulsar locally using Docker, right? So I'm running Docker. This is my personal laptop for personal usage, so not breaching any commercial agreements. And long story short, as part of the test, I start Pulsar up, and after all the tests are run, I stop it, right? So this gives me a clean slate. It doesn't even take too long to boot it, so I'll show you later. And before we got into, the weeds of what the tests do, I'm using some Kotlin functions and functionality that basically like make running this kind of test really easy. So one is, I'm sure you understand it, or you're all Kotlin experts, but long story short, by using by lazy, this delegate here, what I'm making sure is I can initialize this variable without making it mutable. And it will only be initialized lazy when I use it. So what's going to happen here is so if I start basically Pulsar container before using this Pulsar client is going to be initialized to target the address of the Pulsar container running locally, and it's going to happen atomically in one go, right? So it's quite convenient in general. Otherwise, I should have declared it like as a late init var and then like initialize it after the Pulsar container would come up. Because before you start the Pulsar container, there is no address because of how Docker networking works. And so basically you wouldn't be able to connect to it. So these debug probes here, so basically what this does, if you haven't checked it out already, you might want to look it up. But essentially it gives you much better visibility of what's going on in terms of coroutines, if anything goes wrong, or at the end of each test. So it's like if it was a thread dump in terms of like, it will basically like log the state of all coroutines, if they're suspended or not, and so on. So let's get into it. So this one is a really basic test, that I'm showing in terms of functionality. I'm going to walk you through it in a minute. But what I wanted to do is I wanted to show you how it would look if I were to just use the standard Pulsar Java client, okay, without making it nicer with Kotlin. And this is still a Kotlin file, so, in Java would look arguably worse, but to give you a good idea. So here what I'm trying to do is I'm saying, okay, run a test, which gives me like a coroutine scope, which I can use for coroutines. So the main idea behind coroutines, I'm sure you guys all know about it, but is that I can do operations that are non-blocking in a way where it actually looks like it is blocking. So as an example, if you consider this line 60, where I'm waiting for the create async operation on the producer, what's happening is here, the coroutines will actually suspend and resume after this function returns, right? So it's very different compared to how normally it would look if you were to block the thread. And this allows to basically use the resources on your machine in a more efficient way. Now, all of this is probably going to change a little bit with the introduction of Loom, which is actually now available under, you need to enable it with experimental flags. But essentially, coroutines also do more where they make it simple to basically spin up multiple parallel threads of execution and I wait until they're done. Or, basically, the main difference between Loom and coroutines is not like these are just completely different implementation. One will replace the other. But it's mostly like for coroutines, what they enable is for you to do stackful-based reasoning with multi-threading. So the main idea is that if you spin up a thread, whether it's in Loom or not in Loom from another thread, the parent thread doesn't have like an idea of the child thread, right? And so some operations are in things that is slower or more annoying. So as an example, if you need to close resources, it's much easier to do with coroutines as opposed to threads, whether you use Loom or not. So that said, the run test, it makes it possible to basically run coroutines without this test function. And here what I'm going to do is I want to send messages as strings. So I'm using this string schema from Apache Pulsar. And I'm going to create a topic, right? So topics in Pulsar can essentially be either persistent or non-persistent. The difference is that if a topic is persistent, even if there are no consumers, the message is going to be appended to the distributed ledger. I'll talk more about this later. While if a topic is non-persistent, then if no consumers are there, the message is going to be discarded. And also that's like state persistence on the broker itself. So here what I'm going to do is I'm going to basically like ensure that the topic works. This is the one exception, as in it's not part of the standard Pulsar Java client, is a function I created, but essentially like creates the topic and it creates the schema, it registers the topic under a tenant and a namespace. This is another key difference between Kafka and Pulsar. So Pulsar is tenant aware because like it has multi-tenancy built in. So essentially what you can do if you're in a B2B2B kind of context is you can model different tenants within your Pulsar cluster, and you can basically have settings that are per tenant. So as an example, things like you could encrypt the storage of messages with keys that are per tenant, and you can create the same tenant name, the same topic name across different tenants, and Pulsar handles this gracefully because basically this concept is built in. Okay. As far as I know, last time I checked, Kafka didn't have this out of the box. So here what I'm doing is I'm creating a producer, line 60, and I'm also creating a consumer. And after that, what I'm going to do is I'm going to send a message and wait until it's been sent. And then I'm going to receive it and wait until it's going to be received, acknowledge it, which works in a very similar way that it works with Apache Kafka. And then I'm going to check that the value that I sent in the message is equal to the value that I received. So here, one of the pains of using the Java client directly is that these functions that end with async return a completable future that I need to await every time, right? So for everything I need to do, I need to find the version of the function that uses async at the end, and I need to await it. So why could I not just use this receive function instead, right? Well, it works, but the difference is that this one is gonna block the thread, and so it doesn't play well with the coroutine model underneath. So if I run it, unsurprisingly, I mean, it's not much of an output here, but it's gonna basically hopefully work. Here is spinning up the Pulsar container. So as you can see, it doesn't take too long. And let's look at how the test will look if I'm using some extension functions that you can create in Kotlin. Now, one of the very nice features that Kotlin has is that if you mix extension functions, you can basically create your own DSL on top of whatever library or SDK a dependency makes available to you, right? So as an example, if I don't want to always like use async functions and then I wait on them, which is already great because, you know, like going back to it a second, these kind of functions that return a completable future are quite handy if you're in a Kotlin context because you can await them and basically bridge the gap between completable futures and coroutines. Now, as an example, is another advantage of using Pulsar, at least in terms of the Java client, because the Java client itself is built to be compatible with Java 8 or more recent. While if you take the Apache Kafka clients in Java, they're compatible with Java 5. And so they basically give you back a future as opposed to a completable future, which is not simple to await in Kotlin. So if you want to use the Java client for Apache Kafka in a non-blocking way using coroutines, it's not as straightforward. Okay. So here, let's go back to it. So what can I do with Kotlin types? Well, essentially what I can do is I can make sure that with my new types, I can remove all these async await kind of behavior. So here, if you see this function, it's a suspending function, which basically means that it plays with the coroutine mechanism natively, right? Now, the other big advantage is I'm using flows here to basically return messages coming from a consumer, like if it was an RX observable or, you know, like a project reactor flow. I don't know if you guys have used flows before, but long story short, yes, it's similar to project reactor flux or RX observable, and it looks like a little bit like a Java stream, so you can do all sort of like map reduce, filter kind of operations, which is a very nice non-blocking or better suspending mechanism in Kotlin, where for each of these functions, you can essentially map a suspending function to it, and it will handle it according to the coroutines mechanism, right? So here, this is going to be like essentially a hot flow. Now, what's the difference here? In Kafka, if you consume from a topic, you're essentially pulling messages, right? So the Kafka consumer is pull-based. It will keep an offset, whether it's in Zookeeper or not, and it will essentially say, hey, give me the next X messages after this offset. Now, in Pulsar, this is all reversed. So essentially, the way the Pulsar broker works is that it will push messages to consumers, and which is great for latency and so on, but at which point some people might ask, hey, but how does it handle back pressure, right? So won't it risk pushing too much? and too many messages, which might risk overwhelming the consumer in terms of memory and processing power. And long story short, the way it works is quite straightforward. So when the consumer consumes a certain amount of messages, it renews a maximum amount of messages that the broker can send. So essentially, when I create a consumer, you can specify how many messages the broker can send before receiving a notification of things when processed. And it could be like, I don't know, 500, right? And so if you create a consumer with these 500 messages available, the broker pushes messages until it has either delivered 500 of them or until the consumer will have renewed this quota. And so this is all transparent. If you see the implementation of this flow, it's quite straightforward to basically implement this kind of behavior in Kotlin. And the way you do is you can use the flow builder function here. And what you say is, as long as my coroutine context is active, so this gets canceled very gracefully as well, keep receiving messages and emitting them. Okay. Right. So all good. So I'm going to run it. Once again, nothing extraordinary so far. And you should complete pretty much in the same amount of time. There you have it. Now, you can push this even further, and basically you can make the test more streamlined. Now, one of the features that you can use with JUnit is this idea of inner classes and test interfaces, right? And essentially, if you use interfaces, you can provide default behavior, and that basically allows some sort of like multiple inheritance where you can compose functionality as part of your tests. So here I'm creating a nested class like with JUnit. The main idea is that this test will appear within the nested class context, and I'll show you in a sec what it means. But basically, this is the same test, and it's even more streamlined. And the way it works is I'm able to call this function like new persistent topic or ensure that it works. And it all looks a lot easier. And the way this works is because this Pulsar test to port is aware of the fact that there's a Pulsar container, a Pulsar client, and a Pulsar admin. And so here, when I say new persistent topic, I can actually, or ensure it works, I can actually access the Pulsar admin client directly, which basically means that I don't need to refer to it here, okay? I'm not necessarily too much of a fan about this approach because it's very concise, but it's also like, it's not necessarily clear what's going on too much. And so basically, but I wanted to show what is possible. Now, another one that it's interesting in Kotlin is this idea of multiple receivers. Now, this is going to look a little bit weird if you've never seen it before. Now, you guys are probably aware of extension functions in Kotlin. So as an example, I could create an extension function on a string called, I don't know, last 3 characters. And this returns another string, and I can say, I don't know, take last 3, if I got another bell to do, right? And what it means is that essentially you could potentially use it like this. So I can say something dot last 3 characters, right? It's almost like this string is in context within this function, right? In particular, it's called a context receiver. Now, what I can do here is I can add multiple context receivers to a function, whether it's an extension function or not, which basically means that this function will only be available if all the receivers are in the context, right? So if you go back to how I'm using this here, I'm saying with producer, which puts this producer, well, of type Kotlin producer as a context receiver. And then within that closure, I'm saying, hey, with consumer, which also adds the Kotlin consumer as a context receiver. And now message dot is the type, basically, this is the actual context receiver for the extension function. And so what's happening is I can call this function because these variables are in scope. Now, for a second, if I were to remove this function is not available anymore because the producer is in the scope, the consumer isn't, right? Which is quite handy. I mean, it's still an experimental function, but I think once this becomes stable, it will definitely have an impact in how people will build things, because it's quite handy. Now, this function is arguably not the most convenient, so I don't know if in the future, perhaps the Kotlin fork will want to, like, I don't know, facilitate something that looks like this instead. But anyway, so now let's look a little bit at how Pulsar is different compared to Apache Kafka when it comes to partitioning, which is a really big difference. Is also why I personally prefer it. And in Apache Kafka, like, if you know how things work a little bit, which is what this test shows, is the main idea is that you create a topic, and for a topic you create a number of partitions, right? So here, when I'm creating this persistent topic, I'm also like creating a number of partitions equal to 4 on it, okay? And the way Apache Kafka works is that if you have a cluster, each broker is responsible for a number of partitions. And essentially, a partition is a log, right? So when you consume a topic partition, you're basically following a file handle, which implements a log, and this file handle exists within an Apache Kafka broker, which is part of a cluster, okay? Now, this is great because it's fast, and logs are really fast to append only, you know, it's all nice, but it has some problems, which I'm going to talk about in a minute. But anyway, so imagine I create these 4 partitions on a topic. Then what I'm going to do, I'm going to like produce some messages to a topic, and I'm also going to create a consumer group which has 2 consumers. Now, this is a very common concept in Kafka, and essentially, like, when you join a consumer group with multiple consumers, you will have this behavior where partitions are allocated to each consumer exclusively. So as an example, if I have 2 consumers within the same consumer group, and I have 4 partitions, one consumer will exclusively process messages that fall into 2 of these partitions, and the other consumer will own exclusively and process exclusively all the messages that fall into the other 2 partitions. Now, you might ask yourself why, right? So if I'm just putting messages in a queue, why do I want this kind of behavior? Well, this kind of behavior is actually extremely useful when you want to do in-memory processing, because one of the problems with, like, you know, synchronous request or REST microservices is that if you have, like, I don't know, an auto-scaling group in Kubernetes with multiple REST microservices, you have no guarantees that updates for the same business entity, I don't know, for the same user, for the same customer, for the same account, whatever it is, you have no guarantees that those updates will reach the same instance. And so the only thing that you can do in order to synchronize and make sure that you don't make mistakes is going to a database, right? So typical REST application, what you do is you say, hey, go to the database with a transaction, do some operation, come back, return the result, right? And so if 2 parallel operations reach 2 separate microservices, you will create order in terms of like what goes through by synchronizing or serializing in particular on the database. Now, if you're using Apache Kafka or Apache Pulsar, what tends to happen is if you publish those messages to a partition based on a key, so it could be, I don't know, the account ID or the user ID, and you make sure that all the updates for the same business entity reach the same partition, then you got the guarantee that these updates or events or messages will be consumed by the same consumer. And that allows you to do things like batching and flushing or in-memory processing, which are actually really powerful, and essentially like also makes the application logic much simpler. Okay, so here, if I do this, what I'm saying is, hey, I want to check that the same key doesn't appear across multiple consumers, as we discussed. So each consumer will own 2 partitions, and each partition will own a number of keys. And also, I want to see that basically across multiple, each consumer basically consumes multiple partitions, right? As we discussed exclusively. So I'm going to run it. Cool. So I'm still using Apache Pulsar here, but basically I'm using this subscription type called failover, which makes it behave exactly like Apache Kafka works. Now, what's the difference? Well, the difference is that while in Apache Kafka, this is the only possible behavior, in Pulsar, you can have different behaviors based on what you need, regardless of how many partitions you create. So what am I talking about? Well, what I'm talking about is that, first of all, in Apache Kafka, the minimum number of partitions you can have is 1. So a topic is always partitioned, right? So worst case, or best case, depends who you ask, you're only always going to get 1 partition. While in Pulsar, you can create topics that are not partitioned at all, okay? And the reason why is because basically in Apache Pulsar, you can model different messaging patterns, like as an example, queues with round robin and other patterns that are not really available in Apache Kafka. So what am I doing here? Well, essentially, I'm creating a topic which has no partitions at all. But what I want to do is I still want to have this behavior where each consumer only consumes updates from a specific key. So in here, when I do send test messages, what I do is I use messages that are indexed in terms of key. And so what that means is that if that key repeats itself, you're going to get the same consumer consuming all the messages for the same key, even if we don't partition the topic at all. This is something that in Kafka is not possible. So in particular in Kafka, if you create, say, 1 partition within a consumer group, you can only have maximum 1 consumer which is actively processing. Now in Pulsar, you can have as many as you want because this behavior is decoupled, and I explain in a bit why and how is it possible. Okay. So here what I'm saying once again is I'm creating 2 consumers within the same consumer group. I'm using this subscription type called key shared. And this will guarantee that all the messages with the same key will be processed exclusively by 1 consumer or the other using consistent hashing, like if I had 2 partitions or any number of partitions, but without having any partitions at all. Once again, this is not possible using Apache Kafka. And here you go. Okay. Right, so as an example here, I mean, probably like it's not extremely interesting to look at the terminal, but long story short, what you can see is that for each consumer, there are still no partitions. So the partition index is -1 for all of them because there are no partitions, once again. But then if you look at the keys, the updates for the same key are processed by the same consumer. So as an example here, key is 1 and consumer is 1, and here's the same. Or if I take as an example, key is 3, whenever there's going to be another key 3, is going to be the same consumer, okay? Which is really nice behavior. Now, last, the difference is that also the opposite is possible. So in Kafka, once again, if you create 2 partitions, if you have 2 consumers, what's going to happen is that they're going to receive all the messages for 1 partition, 1 of them, and all the messages for the other partition, the other consumer. Now, in general, this is like a nice idea, but sometimes it's kind of like quite annoying because if you got a lot of consumers and you just want to consume things, you might potentially want to go in a round robin way, like if it was a queue. So as an example, if you need to dispatch some asynchronous work to complete, this behavior is not always useful, and sometimes it can limit the throughput in terms of what you can achieve, right? So in Pulsar, once again, you can create a topic which has a number of partitions, but you can still decide to consume this topic like if it was a round robin scenario. Now, the interesting aspect of it is that basically how you want to consume the messages is a decision of the consumer itself, as opposed to the producer and the cluster, right? So in Kafka, essentially, when I create a topic, I set the number of partitions, and this sets how the producer behaves, and how the broker behaves, and the cluster behaves, and how the consumer behaves. In Apache Pulsar, this is decoupled, and so essentially the way you store messages on the cluster is decoupled from how you consume them, and this has a lot of benefits, which I'm also going to talk about in a minute. So in this last test, what I'm doing is I'm creating 2 partitions. I'm telling Pulsar to just consume the messages in a round robin fashion. And essentially here, what I'm gonna do is I'm gonna check that the messages, so each consumer receive messages, contain messages across multiple partitions. Now, this is not a guarantee. In general, I would, because, I can't really predict how the round robin pattern will work, but I'm sending quite a few messages. So this will make it quite likely, right? So it passed. All right, cool. So before we open Q&A, I just wanted to basically mention how this is possible. And essentially, the way Apache Pulsar makes this possible is by using a different storage mechanism as opposed to Apache Kafka. So as I was saying, in an Apache Kafka cluster, once there's a broker, this broker owns a number of topic partitions. And for each of these topic partitions, it has a file handle which models a log. So whenever you, as a producer, publish a message, you decide the partition based on the hash of the key. And essentially, you send this message to a broker using Zookeeper to figure out which broker. And these days, they're working on Raft. But anyway, and then this broker basically appends this message to the file for which it has a file handle open, right? And so when you consume it, you're basically saying, hey, give me the next index within this file handle, the next position. Now, this is quite inconvenient because it has some consequences. So as an example, if I add another broker to the cluster, typically in Kafka, you have to do what is called a partition rebalancing. And what that means is that basically the new broker will have to migrate some data from existing brokers. And in the meantime, things ain't going to work that nicely. Likewise, basically, like if you add multiple consumers into a consumer group, you also have to rebalance how things are going to get consumed. Now, in Apache Pulsar, this is quite different because Apache Pulsar has a different model. So it doesn't use a log model for storage, but it uses like a distributed ledger model. And the way it works is it uses technology called Bookkeeper, which kind of like virtualizes the file system. And how it works is that each broker in Apache Pulsar is stateless. And logically, it is basically responsible for a number of topic partition segments. So the idea is quite straightforward. So if you can imagine like a topic partition, like an append-only log, where you got like the index of the message and the message itself, so you can map it by position. In Kafka, a broker owns the whole long sequence, while in Pulsar, he owns a series of segments within that sequence. So what that means is that the broker ends up being completely stateless. And as an example, you can easily scale up the cluster if you need more processing power, because the brokers are only responsible for brokering and not for storing the data. And so this is also why, as an example, when you add new brokers to an Apache Pulsar cluster, there are no partition rebalancing. And basically, this is much faster and much less inconvenient. With that said, I think I'm done in terms of the presentation, and I'm ready for Q&A. Thanks a lot, everybody. I hope it wasn't too boring or too obvious. It's always hard, like, when you're trying to structure this conversation, to decide what to talk about, not to talk about, because you don't know who the audience is going to be. Thanks again.
All good, thank you. In terms of Apache Pulsar and Apache Kafka, you mentioned that there are a few differences, kind of multi-tenancy, difference in the Java clients and partitioning and things like that. Do you recommend a specific use case for each one of those, or is it how do you choose basically?
Yeah, it's a good question. So essentially, like the way we ended up choosing was running in production with both for a while, because it wasn't entirely clear to us either, right? So it depends. So in general, they're both excellent projects. They're super popular. Kafka has a much wider community, even if Pulsar is also very active these days. It's not like a dead project or an unknown project by any chance. And once again, so as an example, if you use coroutines, definitely like Apache Pulsar, it's easier to work with in this sense. There might be non-blocking clients with Apache Kafka, but I'm not aware of any. The other 2 or 3 big ones is, operationally speaking, Apache Pulsar is a lot easier. Now, what I just said about partitioning, apart from opening all sorts of different consumption scenarios from an ops point of view, is incredibly easier to manage. Because with Kafka, what tends to happen is you're processing a lot of messages, into like big data streams. And when you need to scale, because at some point you will, it's very hard to figure out the correct size of the cluster from the get-go. This is going to be like a problematic operation. So one, it's going to create delays, one potentially is going to create downtime, right? And so that's typically a big advantage. The other big advantage is that essentially the Pulsar Docker image is quite smart, because what it does is it contains both Zookeeper and Bootkeeper, and so it clusters up automatically. So it's an all-in-one kind of Docker image, and so when you add things to the cluster scales organically without you having to manage Zookeeper and Bootkeeper and Pulsar itself separately, right? So another big aspect is like, so as an example, when you're looking about a B2B2B kind of scenarios, like I mentioned, so the multi-tenancy aspect of it is quite relevant. And essentially, why is it relevant? Well, because if you think about, I don't know, financial institutions, they're probably like quite opinionated in terms of like, keeping their data separate. Maybe they want their data with like some, I don't know, data residencies in particular. And you can easily configure this with Pulsar to say, hey, this tenant will have to have these options because it's tenant aware. So in Kafka, this stuff is a lot more complicated. So maybe you need to separate different clusters and so on, right? And then the last one is that essentially Apache Pulsar is completely open source, and there are no features that are behind the paywall or a commercial agreement. So as an example, it comes out of the box with tier storage, which as far as I know is still not aware in Kafka open source. It comes out of the box with geo-replication for topics. And so as an example, if you want to have a multi-region or multi-cloud setup, is another big win.
Awesome, thank you. And in terms of kind of Project Loom and virtual threads, do you have a view on how that's going to impact coroutines?
Yeah, it's early to say. I'm hardly an expert, but my gut feeling is that fundamentally they do different things, right? So the big aspect of coroutines is that they make multi-threaded or parallel, let's say, parallel multi-threaded computations easier, less error prone, right? So you're going to get better stack traces, better resource management, better cancellation, and all things that Project Loom doesn't address. Now, Java, funny enough, is also working on structured concurrency. So there are actually a concept of a scope for multi-threading. But the thing is, the fact that it's kind of an afterthought doesn't make it as nice or as easy as Kotlin coroutines, right? So I think actually Kotlin coroutines will benefit from Loom. They work straight out the box with Loom. So all you have to do is create a virtual thread executor and turn it into a coroutine dispatcher. So it's not particularly hard. And I'm looking forward to the support that Kotlin will eventually add in terms of like the core library itself.
Cool, thank you. So do you have a view on what the advantages are of Kotlin flows over Project Reactor's Flux and RX?
Yeah, it depends on a couple of things. So first of all, do you guys still see the code, by the way?
We can switch back to the code if we need to.
I don't necessarily, I can or cannot, doesn't matter too much, but yeah, you guys see it?
Yep, we got it.
All right, so as an example, one of the differences, I don't have Project Reactor, but just to show you what I mean, right? So as an example, if I create or integers, let's say, as a flow of 1, 2, 3, right? So one of the big differences is that, as an example, if this was a Flux or an observable, you would have this double behavior. I don't know if you guys remember about this, right? This map or flat map. And essentially the main idea is, given that Flux and observable, they work with this concept of monads, with the various single or mono, the main idea is, as an example, if you want to apply an operation which does some I/O to each element of a flux, you would have to use this flat map, which basically takes a mono in it, okay? And the difference is that if you don't, and you use a normal map operation, then what you end up getting is a flux of monos, which is not typically what you want. And so in Kotlin, this disappears because the fact that the language itself is aware of suspension makes sure that, as an example, I could have do something as a function down here, and then I could have a suspend do something else. And I could apply, oops. And essentially, if this maps something, I don't know, takes an integer in both cases and can return an integer, right? Make it particularly complicated. If case, here what I can do is I can say, hey, map do something, and map do something else. And this works whether these functions are suspending or not without having to take this aspect into consideration. The other nice aspect is that it works transparently with coroutines. So as an example, if I want to say integers dot on each, I don't know, print it, and then map, I don't know, it squared, right? And then I want to do collect, this will suspend and give me the results here, right? So squared and printed, right? But as an example, I would also do integers dot, I don't know, I could also spin up these easily into a separate. So as an example, I can say, give me this async, do the same thing, right? Do this, and essentially, again, and this is asynchronous, and it will basically, I can basically wait on it, I can compose it, and it just plays very nicely with the whole coroutine context. So that's kind of like the difference. Performance-wise, it's probably also faster because it doesn't have to do a lot of intermediate operations. And the exception, so this is the last big advantage, actually. The exception that you get with like Project Reactor and like observable from Rex, they tend to be like really convoluted. And the reason is because you lose the context of where the code was. So as an example, if you map a function to an observable, it's not necessarily that easy to figure out where that happened. While with flows, it follows the normal. So as an example, I can try catch an operation on a flow, and if it throws an exception, it's actually caught by that try catch. If you ever use like observable or flux, you know that is definitely not the case there. It's a little bit more annoying. Cool.
Excellent. Thank you. I think that's all we have for the questions. So I'll get the link out to the code repository that you sent out. I'll make sure everybody has that. And really appreciate your time. Thank you.
Thanks a lot. I mean, really glad that we got this chance. Thanks, guys. Have a good rest of the night.
Awesome. Thank you. Can you just chuck the last slide on? Cool. So our next Brighton Kotlin is in September. We've got Robert Elliott from WireMock. He's the principal engineer at WireMock. He's going to do a talk on HTTP for K and testing with WireMock. So we're looking forward to that. And Silicon Brighton got a Slack community. So by all means, take a look. It's full of cool people. Everybody's willing to help. So take a look. And thank you for coming. Cheers, buddy. Thank you.